Okay, this is Brian from Marbach, and he's going to show us how to load the machine and get a job running on the machine. This is a steel counter.
All right, so very important, you want to make sure that the table bed is clean. As you saw earlier, we had sanded the backside, got it clean, make sure we have no burrs. Just be very careful as you're cleaning the table off. As you can see, we have vacuum holes. So I just removed all debris, all burrs at this point. I can load the plate. So some plates are symmetrical, others are not. It's important that you have the plate positioned as the same you see in impact. Over here we keep our locator pins. What we do is here on the machine is a 0 reference point. I always place one in the first hole, place another in the second hole on the left side, and then the third pin I always place as far as possible. So we will place it in that area. Now at this point, you want to pull the plate in, ensure that you are located against the pins. Okay, as you can see, I'm against the pins at this point. Pull the monitor over. This key is where we control vacuum off and on. So apply a little pressure, hold the plate in place, turn the vacuum on. Now the first thing I do is I grab the pins and ensure that I cannot rotate the pins. That lets me know that the plate is in good position. And now at this point, we need to tape the remaining section of the bed. Based on the size of the plates, you can create some Roma masters so that you don't have to use so much tape. I would suggest getting some type of other tape, something that is wider so you don't use as much, but for now, masking tape will work. And just FYI, we do sell Marbach tape.
Of course. They are covering the holes, the suction holes, with the tape, as to increase the vacuum on the plate.
Very important, you want to make sure that you have at least 0.8 bars. Here, you can read your gauge. So you want 0.8 or above. At this point, once I get the top in the right tape, I remove the pins. They can be a little tight. If you can't pull it out, just grab you a pair of pliers and remove the pins. Very important to remove the pins, otherwise it can get in the way of the spindle.
Please notice the pressure at 0.89 bar after all of the loose holes were covered. All 4 sides of the plate have been taped, secured to the table. The plate has been placed on the table with the center bow up and the edges tight to the machine.
Okay, now at this point, we're going to go through the process of using impact and Mgrav, doing the programming from the impact side, entering our tooling information in Mgrav, and then we will grind some tools So I'm going to switch over to the CAD PC.
And what he's doing here to switch over to the CAD PC.
You're going to press the wheel and right click. That allows you to switch back and forth between the controller and the PC. So now at this point, I'm opening Impact, and we're going to retrieve the file that we want to mill. So here, I'm going to click on the browser. Now you guys will just determine where it's located, what month. Now, which plate do you want to run?
Steve, what's that die number?
Steve? 11254. Okay, so it's this file here, so I'm going to open this file. I say yes. This is the plate that we're going to mill. If you do not see your K-pallet layers, just click the visibility box, and now we can see our K-pallets. Now what I'm going to do at this point, I'm going to keep my arrow in the blue area and right click and turn all pallets off, select none, and I'm going to turn the counter text on. I'm going to highlight the counter text with Control A, or you can use the mouse, drag it, and highlight it. Now I'm going to change that palette to 2K29 for counter text, and click OK.
You didn't get the other one, I don't think.
Yeah, let's see, let's turn K29 off. Nope, so Control A, I'll highlight both, change to K29.
He selected K29 on the pallet box.
Good?
Yep.
Okay, so now I'm going to turn my K pallets on that I want to use. And the steel profile, very important so that the machine can read the location of the plate.
Just for the purpose of this job, Brian turned on K01 with grain channel, K06 channel, K07 counter channel, and then K29 the counter text and the steel profile.
Now at this point we're going to plot the job. If you had maybe a 30 up, you had multiple channels, you can always split the K pallets. But on this job we do not need to do that. So I'm going to hit Control P.
Control P.
Or you have another option. You can always go to File and Plot, or you can plot the job from here. So you have three options. All keys will do the same thing. Important, when you're running steel counter plates, you're going to select Hub Mgrav. If you were going to mill a phenolics job, you will select Realma, and this will change the machine and the post-processor. You have two different post-processors, one for steel counters and one for phenolics. So I'm going to go back and select Hub Mgrav for steel counter, and here you will see export to Mgrav. So now what we do is we highlight the number, and we're going to copy, and we're going to plot the job. You click OK because we're not going to output these pallets. Last, we will click OK. That is going to send the file over to Mgrav. So now at this point, on the bottom here, we're going to open Mgrav. File. Import. And then you always want, by default, normally this is going to be highlighted for ISO. This is the one you want to use, the format. And you click OK and import. All right, now what we're going to do, we're going to right click and paste that number in the file name. Now we will open the file. And there's your steel counterplate. At this point, you're going to click escape, and that's going to deselect the job.
As you can see, it's all pink, indicating that it's selected.
And it's very important to hit escape because you do not want to shift the job. All right.
Escape, now the geometry has all been deselected.
Okay, so now we're going to go to path generation, operations list. Okay, so I set up a default for the counter text, so always you're going to see the K29 palette and the depth, the tooling information, and all the tech object is already pre-selected for you. So now we're going to set up our K palettes. The K palettes I'm referring to is in your impact file. Here you will see K1, K06, and K07. So I'll go back to Mgrav. And what you do is you double click all. This box pops up and you select your K palette. So I need K1, K6, and K7. Now, if you have channels that have different depths, you must set up a K palette for each one if you need different depths. If the depths are the same, you can apply to the same layer. So I'm going to click OK, and now you can see 1, 6, and 7 is selected for that tool. Now at this point, what we're going to do is we need to know what size tools we need to grind, the depths, and the channel information. And the way you determine that, verify on your paperwork the paper thickness. So for this job, we will look on the paperwork and we can see the caliper is 0.016. So now reference your chart and we can see for a 1mm plate, your width grain is 1.52, against grain is 163, and your channel depth is 0.51. Always select your smallest channel when determining your tip diameter. So now at this point, we are going to open the Excel chart and we will enter that information here. Now we have depth at 0.51. Always channel tool angle is going to be 15 degrees, and we enter the smallest channel size, 1.52. Click in the open box, and it tells us max tip diameter for your tool cannot exceed 1.25. So we're going to grind a 1mm tool. So now we have our K palette selected. We will enter our depth. So that is 0.51.
Why did you select 0.51?
Because the chart tells us that we need 0.51 depth for a paper thickness of 0.016.
Thank you.
No problem. So now we know from our tooling chart that we're going to use a 1mm 15-degree tool. If you need to change that information, you click the edit box.
Our standard channel tools, 15 degrees.
What we do now for the geometry data bank, we click copy. It shifts the information over. If you needed to grind a 0.8 tool, 15 degrees, you just change your tip diameter to 0.8. You will get this information from your specs in your tool diameter chart sheet. So we're going to minimize that. We go back and we know that we need a 1mm tool. So I'm going to enter 1 point. And now we have a 1mm 15-degree tool. The diameter will always be 6mm because that's your shank thickness.
And will the channel tools always have a 15-degree angle?
Yes.
Thank you.
So now we click OK and Save to Workpiece. And now what we need to do For your channel tools, this tool compensation box here says auto. That is default, so you will always see auto there. For some reason, if you do not, please select auto. Okay, so now what we need to do is set the feeds and speeds. We have predetermined and preset these speeds and feeds for you, but for some reason, if the information is not there, we will open a feed and speed chart. So now we're going to go to the computer for the PC, open it. I have this saved in the D drive. Excuse me, I have it saved on the C drive. And you will see feed rates. Double click feed rates and you will see your Excel sheet. Open it. And here, depending on the material thickness, I'm sorry, the material hardness, this box, as you can see